Let me share my screen. Okay. There is an example, says that given the system below, design the system such that it can operate with a peak time that is 2/3 of that of the uncompensated system. It means that I need T peak new be 2/3 of the T peak old, and also I need 2%, 20% overshoot with zero steady state error. Steady state error system should be. These are the targets of our design. So for a step unit, these are the targets, and I want steady state error to be zero. So I'm using PID controller. So PID controller is used here. First, I have to understand the uncompensated system. So step one is saying, so step one, so I'm showing the steps here. I'm not solving the problem completely, but to understand what is going on here. Step one is to say the zeros and poles of the system are like we have -8, -3, -6, -10. These are the open loop zeros and poles. So I have two infinities and nothing here. So if I want to draw the root locus of the system, I can say at -3, and I have -6. Let's make it more scalable. -3, -6, and I have at -8 and -10, something like this. Here is root locus based on the odd number on the right. Here is root locus. So this is pathing here. And this one is going like we have sigma. We should find sigma A is like -3, -6, -10, -8 over 2. So this means that it is like -19, 11 over 2 is -5.5, and the theta a's are 2k plus 1 pi over 2, so it is pi over 2 plus minus. So my asymptotes are about here, and also I have to find d of k, sorry, d of k over d of sigma equal to 0, and this means sigma is about 4.6 minus, that is the breakaway point. So about here I get something like this for the root locus of the system. So uncompensated system is working like this. Overshoot is 20%. So step 2. Let's go to step 2. Step 2 says that overshoot of the system is 20%. So zeta would be, I know that exp of minus zeta pi over 1 minus zeta 2 is the overshoot. From here I can find zeta equal to 0.456, and cosine of theta equal to zeta would be, give me the theta. So if I draw this line, let's say like this, this is theta. I get this here is 170.30 degree, and this is the condition that system is working on. So I have it here, and I have here two poles, the current system, step 2. So step 3 is like saying KGH should be -1. S is sigma plus J omega D, and tangent -1 of omega D on sigma is equal to theta that I have. From here, I get that K is 121.5, omega D is 10.57, and sigma is -5.47, and that's all. I find 3 things. So what does it mean? It means that here is 10.57, here is -5.4, and at this point K is 121.5. Okay, this is the condition that I am finding the system. Now if I want to go to the design, let me add some page to it. Okay, and say that, okay, now my T peak of old is P over omega D, which is pi on over 10.57. Okay, this means that this is about 297 seconds. Now I want T peak new to be 2/3 of T peak old. So this means 2/3 of 0.97, 2.97. I need it to be about 2, yeah, 0.2, let's say 0.2. So this means omega D new should be 3/2 omega D old. So this means that omega D new should be about, let's say, let me find the calculator. So this means that 10.57 multiplied by 3 over 2 should be like 15.85 radians over second. So this means that I have to be, let's say here, which is 15 instead of 10, and with the same overshoot I have to go to A prime here, but the root locus is not passing A prime. So I have to add some zeros and poles to the system so that I pass through that point. Let's say I am adding, so this part is important. This is step 4. Step 4, add S plus ZC such that new root locus passes through A prime. How do we do that? We do it like this. We say that, so it is not like we have to trial and error everything. It is like this. So also I had to check the third order approximation is working. I forget about that. I can say the third pole is here. So here's 0 pole cancellation. So second approx is okay. So I have to mention that. So -3, -6, -8, minus 10. I need the new point 50.85 on this line. On this line, let's say, this is the A prime. Okay, so I know that that point, which is A prime, okay, is like my figure is not very well in this term. Let me make it better, because the 15 is not there. Let me show it. Like this. If this is 15.8, this should be 10, okay? So I have to scale it better. And this is the, let's say, 170 zeta line. This is the A prime, okay? A prime is on 15.8 and minus 8.3. What does it mean? It means that if I want A prime to be on the new root locus, okay? And this is new 0, which I don't know where is it. I have to do this. I should say that theta 1, this is theta 1, theta 2, theta 3, theta 4, theta of compensator. Theta 1 negative minus theta 2 negative minus theta 3 plus theta 3 minus theta 4 plus theta c should be 2k plus 1, 180. Okay? So, according to this, I can say that theta c, all of these theta 1, theta 2, theta 3, theta 4 are known, because I know the starting coordinates of the arrows and end point A prime. So according to this, I can say that theta c should be about 18 degree, okay? Being 80 degree means that here is 50.8 A prime. Here is 80 degree. So this point becomes about some value, let's say about 47, when tangent of 80 is about 50 over 47. So this means that ZC should, because this is 8.3, as here, this point is 8.3 from A prime, ZC should be 50.3. Let me add another page again. Oh. Let me explain this here again. So, theta 80 degree, this means here is minus 8 and 50.8. So here becomes 47 from tangent of 18. And this means that Z of C should be about 50.92. Okay, this means that I should have a UG in the form of K S plus 55 plus 92. What was the rest? S plus 8, S plus 3, S plus 6, S plus 10. So in this condition, I have like minus 3, minus 6, minus 10, and I have minus 8, and I have like minus 55.92. So here is root locus, here is root locus, and here is root locus. So if we find the thing, it is like it goes from here to here, but this one, these two come from here and go there. One of them goes this way and like this. One of them goes this way, infinity. Okay. So in this condition, the point that is here is like this. Of course, again, I have not drawn it very well. Let me show that. Minus 8, minus 10. So this is like something like this is happening. Here we have the A prime point, which is plus 50.88. Now, what is met? What is met here? TP has become 2/3 of TP, means that transient response is met. Okay. Now, to make steady state error 0, what I have to do is to add the PI. What was the PI? PI was adding here a 0 and pole like this. This 0 and pole means that my G nu, I wrote the same color, K S plus 55.92, S plus 8, S plus, let's say, 0.1 divided by S plus 3, S plus 6, S plus 10, S. This will guarantee that steady state will be 0 and also guarantee that transient response will change very ignorable values. So the process is like this. When we do first the PD compensator, what happens is we change the transient response, means we change the root locus from this original to this different one. And when we change this, when we do this change, then we do the PI, because PI is guaranteeing us that the steady state error will be 0, and also the transient response, the transient response is not that much affected. What is K also? If you want to discuss what is the new K here, I have to find the new K value. In this condition, A was 121, but here this point is 50.88 and minus 8.3, and k. How do we find k? We say k, g of nu, h of nu equal to -1. From here, k will be 5.34. So we have to, as I said, I'm showing the procedure. I'm not giving all the details. All the details are like we have to check these 8 steps and 80 steps here. So in the exam, it is like we give some of the details. I solve this problem for you, and then I say complete, for example, this table. I give you such tables. Let me show such tables, and I put some of the values blank. You have to fill in them. So just you have to know what we are doing here. Okay, you have to know what is the procedure. But in your final project, you're going to show step by step what you have done and explain why you have chosen such extra things. Any questions? No question? Okay, please do the practice at home. Have a nice weekend, and we will meet next week in person.
Thank you.